So what we're looking at finding the values of x and c for the matrix problem that we have here, the matrix equation. And if we look at this by examination, we recognize we're multiplying the two matrices on the left hand side of the equation, and we're adding the two matrices on the right hand side of the equation. And the equation, we have an equal sign here, we have a left hand side, and to the right of the equal sign we have a right hand side. So when we multiply these two matrices and when we add these two matrices, we should get entries on this side being equal to entries on that side. Alright, let me do a quick explanation of what I'm talking about there. What I'm saying there, if you have two matrices being equal, there's a principle that we should be familiar with. If you have these two matrices being equal, so let's say this, we have a 2 by 2. Let's suppose we have a 2 by 2 matrix. We have A, B, C, and D being equal to another 2 by 2 matrix, E, F, G, and H. Then we can say, because these two matrices are of the same order and they're equal, it means that the corresponding entries are equal. So A is the same in value as E. So we can say A is equal to E. And B, same in value to F. So we can say that B is equal to F. And we can say also that C corresponds to G. In other words, C is equal to G. And D corresponds to H based on its position and everything. So we can say that D is equal to H. That's the principle. So what I'm saying here, when we multiply these two matrices, we should get a particular matrix. In fact, let's decide what kind of matrix we're going to get. We have 2 rows and 2 columns, so this is a 2 by 2 matrix. What kind of matrix I have there? I have a 2 by 1 matrix. What kind of matrix I have here? I have a 2 by 1 matrix, and this is also a 2 by 1 matrix. Okay? Now when I multiply these two matrices, what will I get? Well, there's some principles that we should be familiar with. In order to multiply two matrices, the inner number should be the same. In other words, the column of the first should match the row of the second. Because they're the same numbers, it means that we can multiply them. We're allowed to multiply them because these two numbers are the same. Row, column, row. Column of the first, column of the first, row of the second. Once they match, we know that the two matrices can be multiplied. And the resultant matrix will be these numbers outside. Row of the first, column of the second. So the resultant matrix, if you look at it, would be what? A 2 by 1. So, okay, so if you multiply these two matrices, I'm going to get what? A 2 by 1. So my 2 by 1 will look something like this. Let's use letters. Let's call the first letter M, the first entry M, and the second entry N. This is a 2 by 1. How we know it's a 2 by 1? It has 2 rows but only 1 column. So when I multiply these two matrices, it will end up looking like this. One number over another number. Okay? This M could be an expression. For example, 5p plus x, that's one term. Okay? But anyways, I'll look at that when we get there. Now, next thing we should note is that we have the equal. So we have these two matrices multiplied and we'll produce something like this. And when we put the equal sign back there, when I add these two matrices, now look at it. Unlike this where we're multiplying, in this case we're adding. You can only add matrices if the entries correspond. So 8 correspond to x, y correspond to y, because they're in the same position. Same positions. And so we can add these two matrices. We can add 8 plus x and we can add y plus y. Okay, that's something we should note. So a 2 by 1 matrix plus a 2 by 1 matrix will also produce a 2 by 1 matrix. Let's give it some other letters. Let's use P and Q. So if I add these two matrices, I'll get some matrix P and Q. If I multiply these two matrices, I'll get some matrix M and N. So what is it saying here? Now I have two matrices being equal. The product of these two matrices equal the sum of these two matrices. And once they're equal, we can now equate them. What would we say? We'll say M is equal to P and N is equal to Q. And that's the principle. Why? Because these two matrices are now equal, they have the same order. In other words, we can say that the corresponding entries are equal. And that's the concept right there. Okay, so you can always review this video and look back at what I was saying to make sure you get the the good understanding. Alright, so as I go through it, you'll understand it a lot better too. Alright, so let's deal with that now. I'm going to take off these. Sorry about that. Let's take this off quickly. Alright, good stuff. Alright, so I'm going to multiply these two matrices now. Multiplying them, it will be 1 times 3. So remember, it has to be what? Row by column. Yes. And so entry by entry, corresponding entry by corresponding entry. So let's look at that. So we're going to get what? 1 times 3, that's the first entry. Alright, 1 by 3, that's 3. Alright, so the first entries, corresponding entries, plus the second corresponding entries, negative 2 by negative 4. Sorry, negative 2 by negative 2. Negative 2 times 2x. That will give us negative 4x. Okay, let's go over that again. 1 by 3, that will give us 3. Correspond in the entries there. Negative 2 times positive 2x. 2 2's give us 4, and negative times positive is negative, so it's negative 4x. Now I'm finished with the first row, and now I'm going to move on to the next row. Why am I moving on to the next row? Because we have no more column to multiply this row by. So I move to the next row. Because I'm going to the next row, I'm going to have to shift down here. So I'm going to go to the next row down here in my result, because I'm going to deal with the next row. Now do the same thing, row by column. So it's 3 times 3 will give us 9, plus 4 times 2x, which will give us 8x. I finished multiplying the row by a column. There's no more columns, so I will simply leave that as it is. We're done with multiplying out these two matrices. Now principle here, we're not multiplying. In this case, we're doing what? We're adding matrices. And because both matrices are of the same order, we can add them. And so we'll say 8 plus x is 8 plus x. That cannot be simplified any further since x is unknown. Y plus y, well, if you have one y and we're adding another y, in total we get 2 y's. Okay? That is simple and to understand. Why we didn't say 8x? Well, in this case, because we don't know what this number x represents, what it is. So we say 8 plus x has to be 8 plus x. We have one y and we add another y. These are like terms, and like terms can be added. But these were unlike terms, and so we leave them as they are. Like terms can be added, so 1y plus 1y gives us 2y. Okay, that's the concept there. Okay, so if you look at it now, we have these two matrices being equal. Notice that 2 by 2 matrix equal to a 2 by, sorry, it's a 2 by 1 matrix, sorry. We have 2 rows, and this is 1 column. Okay, because remember there's a plus sign in between here. Unlike up here, we didn't have a plus sign between them. So we weren't adding these two entries, we weren't adding these two entries. It's separated, they're separated. In this case, these are attached. This is one term basically, it's an expression. A two-term expression called a monomial. So we have a one term and another term. 2 by 1 equal to a 2 by 1. And once they're equal, when two matrices are equal, what did I say before? The corresponding entries are equal. So we can say, well, 3. And plus minus is a minus. Okay, so we can say 3 minus 4x is equal to 8 plus x. Okay, efficiency, plus and minus, is going to give you a minus. 9 plus 8x, well, we have to leave that as they are. Those are unlike terms. Equal to 2y. Okay, now we're going to look to solve those. Now we can solve the first one above. We can't solve the one below because the equation below, so call this equation 1, and call this equation 2. Equation 1 can be solved for x. But equation 2 has two unknowns we can't solve. So the best thing to do is to solve for x. And once we find the x value, replace it here. And we'll only have one unknown in that instant, which will be y, which we could solve for then. So let's solve for x. It's going to write back this first equation. 3 minus 4x is equal to 8 plus x. Grouping like terms, For me, I can actually see that it's better to carry the 4x over here, and then I'll carry the 8 over there. Why? You'll see. X is already over here, so I leave it as positive x. The negative 4 becomes a positive 4x. To me, it's more easy to work with that way, because I know I have my x being positive. So I have positive 5x. Now my 8 going over, so looking at this side, I had my 3 over here originally, so it stays as positive. The 8 goes over, so each sign in front of it changes to negative. And different signs, I will find the difference between the numbers, which is 5. In other words, I subtract and keep the sign in front of the number that is bigger in quantity. So I have more negatives than positive, and therefore my answer should be negative. Okay, so I'm going to divide both sides by 5 now, because I want to find what 1x is. 5 and 5 goes 1, so that's 1x, which gives me x, or 1x. And I have to divide this side by 5 as well. Keep both sides balanced, and that will give me negative 1. So I found x to be negative 1. Now think about it. Now I know what x is. Let's write back the second equation now, equation 2, which is 9x plus 8x equal to y. So I know what x is. I made a mistake here. This should actually be 9 and not 9x. So let's take out that. Okay, so I have 9 plus 8x equal to y. 9 plus 8x equal to y. And what I'm going to do, since I have two unknowns, I won't be able to solve for y. So I need to replace this x, because I have its value already. So I'll have 9 plus 8 times x, and x is negative 1. So it's 8 times negative 1 equal to y. And so I can solve for that now. So I'm going to have 9. Now I'm multiplying positive 8 by negative 1. So positive times negative is negative. 8 times 1 is 8 equal to y. Okay, not difficult at all. Very simple stuff. And 9 minus 8 is 1. Now, different signs, I find the difference between the numbers and keep the sign in front of the larger, since 9 carries positive. And we're going to have 2y there. Now, I need to find y. And so, 2 times a particular number gives me 1. Well, the only thing we can say that must be a half, because a half of 2 will give me 1. So what I need to do is to divide this side by 2 to get my 1y. Because I did that on one side, I do it to the other side. So I'm going to have y being equal to what? A half. Okay? And so that's my solution. You can always double check to make sure your answers are correct. So what I have is x being equal to negative 1 and y being equal to a half. Okay? We can always double check up there, but at the present time, time is running out. So let's leave it as it is.